Last section that we're going to be talking about is piecewise functions. These are the ones that had all the parts. You get to be able to identify what each one is, and then you can graph it. So we have to start with building our wall. And I usually use I'm going to do my highlighter for my wall. And so my wall is going to be, when there's just one set here, it's just going to be one wall. So my wall is at that -4. I do it in dashed so that I know it's not really there. But it's just a helping guide point. Next, we need to identify which way am I going in each section. So here I'm going to open circle and I'm going back to the left. Here I'm going to have a closed circle and I'm going to go right. And then the last thing we need to do is identify what type of shape are we having. So this is a linear, which means I need to find the point and the slope. And then this next one is linear as well. And I know it's linear because there is an x involved with no power and there's no absolute value. So let's go ahead and find those two things for each of these. So let's take the first one, y equals 2x plus 7. And I want to find out what's happening at that wall, so -4. So y equals 2 times -4 plus 7, so that's -1. So my point is at -4, -1. So I'm going to go ahead and plot that, -4, -1, open circle. Now I'm going to find my slope. My slope on this one is 2/1. My arrow says I need to go back to the left. So if I'm positive going left, that means I need to fall until I run out of graph. And when I draw in my line, I need to do a solid line with my arrow ending up on the left-hand side. So now let's go ahead and do my next one. And so again, I have a line. Let me choose a different color. And so I have y equals -1/4 of my x. So y is equal to -1/4 of -4, which is 1. So my ordered pair is -4, 1. Come in here and we'll put the dot, and it's going to be a solid dot. Now I need to take and move my slope. And so my slope in this case is going to be going a -1/4. So as I'm going to the right, that means I am falling. 1, go right 4, 1, go right 4, 1, go right 4. And so I'm going to draw that in. And that gives me my second graph. So unless you see at the wall where you have a hole and a filled in, if you don't see it where both of them are the same wall, then your domain is not going to be this, but your domain is usually negative infinity to positive infinity, unless you have two that are holes on top of each other. The next thing that you're going to do is you try to find your range. And remember, range is low up till we hit our high. So if I go from low, I hit a gap here, but if I look, I've got this other line covering it there. And so it really just stops here at that 1 value. So I go from negative infinity to 1, including those 2 points. So now let's look at number 2. So I need to figure out where is my wall. So my wall is at 1. So I'm drawing a vertical line at 1, going up and down. And when I'm going for the top one, it's going to be an open circle, and I'm going to the left. The bottom one's a closed circle as I'm going to the right. And so next thing I need to do is identify what type of lines I'm working with. The top one's an absolute value, which means I need to find the vertex and slope right and slope left. The bottom one has an x involved with it. There's no absolute value, so it's a linear, which means I need to find the point at 1 and my slope. Based upon this, I need to find my slope going to the right. And so let's go ahead and do each of those pieces. Let's start with our top one. Y is equal to the negative absolute value of x plus 2, and there's not anything outside, so I'm going to put a plus 0. So my vertex is negative 2, 0. So I'm coming over here to negative 2, and I'm at 0. That's my vertex. Now let's move with my slope. My slope going to the right is going to be a negative 1 over 1. So that is down as I go right. Slope going left is a positive 1 over 1. So as I'm going left, I'm also going to go down. And so when I hit this wall is the first time I need to really worry about what the sign is. There's no one bar underneath it, so it's an open circle. Everything else is closed dots as I'm going through and graphing these. So let's get my absolute value graphed. So I'm going to the left, I have an arrow at the end. And then as I'm going to the right, I just have the line. So now, let's go ahead and do our other graph. We have y is equal to 3x minus 5. And so I first need to find out what's happening at the point whenever x is equal to 1. So y is equal to 3 times 1 minus 5. So y is equal to negative 2. So at 1, I go to negative 2, and I'm going to put a closed dot. Next, I'm going to move my slope. I need to do my slope going to the right, because that's the direction I need to leave. And so it is 3 over 1. So if I'm going right, then my top needs to go up. So 3 over 1 until I run out of room. And, oops. There's your graph. Now let's find our domain and range. Our domain is negative infinity to infinity because we have a open filled in with a closed. Range. My lowest value is down here with this arrow. I'm going up and I'm going to cover everything in the middle until I get to this top arrow. So negative infinity to positive infinity. So let's look at number 3. And so when I'm looking at number 3, I've got 3 different things this time. So I'm going to have, instead of just one wall, I'm going to have 3 walls, or 2 walls, 3 sections. So -6 is my first wall. My second wall is at 4. And so in this first section, I'm going to have a filled in dot, and I'm going to go to the left. In the middle section, I have an open dot, so I go to the, and then I go to the right, and a filled in dot, and then I go to the left. And then in this last section, I have an open dot as I'm going to my far right. So now let's identify each piece. This top one's a linear. So that means that I need to find a point. And the slope, and this time I want to find the slope going to the right, or excuse me, going to the left. The slope as I go left is how I'm moving from there. I'm not having to change anything, no changes, but I need to find that. This middle one's my constant. So that means it's a horizontal line. And so I'll just go ahead and find my two ordered pairs at -6, 5 and at 4, 5. And so I'm going to go ahead and plot those. -6, 5 has an open circle, and 4, 5 is a closed circle. Draw my line in between. And there we have the middle section done. My last section is absolute value. So that means I need to find my vertex. And then I need to take and find my slope right and slope left and graph those. So let's take the top equation. Y is equal to -1/2 of x plus 2. And so I need to find that point. So that means I need to plug it in. So -1/2 of -6 plus 2 gives me 3 plus 2, or 5. So my ordered pair is -6, 5. And when I look here, I'm filling in that hole. Now I need to do my slope going to the left. It's going to be the same both ways, so -1/2. I need to go left, and I'm negative, so that means I need to go up. And then I'm going to draw in that line. As I go up and to the left. Then my last section is y is equal to the absolute value of x minus 2 minus 3. I need to find my vertex, which is at 2, -3. So 2, -3. Well, that's in the wrong section, so I'm going to put an x there. So I don't need to go that way. I only need to go to my right. So when I graph this, I only need to look for the points going right. So all I need is slope going to the right, which is 1/1. And so as I'm going from there, I'm going up. As I'm going to the right, here's the first place I have to graph. And so I have an open circle, 1/1 each step. And then I'm going to graph that in with a line. And here we have it. Now, when I take and identify my domain is -infinity to +infinity. And my range, my low point is down here, and my high point is with an arrow. So that's going to give me an open, so it's going to be open circle here, so that's going to be a parenthesis at -1 going up to +infinity. Number 4 is a piecewise function, and so the first thing we do is we start with graphing our walls. So our walls come from over here, and so my first wall is going to go up at +1, and my second wall is going to go up at +5. And so now I'm going to graph each of these other functions. And so let's first identify what functions we have. So this top one is absolute value. So I'm looking for that vertex. This next one is a slant graph or a linear function. And this last one is a horizontal graph or a constant function. And so now we'll look at what pieces go where. So for my horizontal graph, I'm looking at a filled-in circle and going back to the right. For my linear graph, it's between two locations. And I have an open circle going away from those two walls, going towards the center. And the last one I have is an absolute value function. And it's going to be in closed circle going back to the left. So let's find each of those pieces. So start with the absolute value. Y equals 4/3 times the absolute value of x plus 5 minus 3. So I find the vertex by doing opposite, same. And so my vertex is at -5, -3. So I'm going to come over here to -5, go down to -3, put my dot. Now my slope going to the right is at 4/3, and it's a +3, so it's going to go right and up, or +4/3, so it's going right and up. And our slope going left, we change the sign to -4/3. I'm going left, which takes care of the negative, and so I'm still going up. Those match, so that's telling me I did it right. So if I went up 4 to the right 3, up 4, right 3, and at that wall I'm a closed dot, so I'm going to go ahead and fill it in with a closed dot. Now going back to the left, go up 4, left 3, and now I'm going to draw in those lines. So the arrow is going to, no, not draw yet. Okay. So as I go to the left, I'm going to continue forever. As I go on to the right, I'm going to stop when I hit that wall. So now let me graph the middle one, which is my linear graph. So it's y is equal to -x plus 6. And so I'm going to plug in two different points. I'm going to have one where I have an x at 1 and one that I have an x at 5. And so y equals a -1 plus 6. So -1 plus 6 is 5. And so I have y is equal to a -5 plus 6. And so I have an ordered pair of 1, 5 and 5, 1. And so I plot that. That's over here at this spot. And so it's an open circle, but it really doesn't matter because it's kind of filled in there. Going down here, we have an open circle at that one. Connect those two dots. And the last one we have is that horizontal line where the x value is at 5, the y value is at 1. So I have a starting off at 5, 1 and going back to the right? So on this, my domain is negative infinity to positive infinity, and my range goes from my low, which my lowest point is down here at -3, and I go all the way up. Well, if I look here, I have an arrow going up, so I'm going to go up to positive infinity. So from -3 to positive infinity. And the last little bit of the piecewise function graphs are going to be, or piecewise functions are just going to be where you have to evaluate. And when you're having to evaluate, you have to first determine which one of these rules it fits into. And then after that, do the math by the first. So let's look at what this first one, -3. So we got to see, is -3 less than 1? Yes. So that means I'm going to use this function. So negative x minus 9. So that means I have a -3 minus 9. A -3 means it's a plus. So 3 minus 9 is equal to -6. And that is your answer. So when I look at the next one, 7, look to see which of these does it fit into. Is 7 less than or equal to 1? No. Is 7 between 1 and 5? No. Is 7 between 5 and 9? Yes. So I have 2 times the absolute value of 7 minus 3. So that's 2 times 4, and we're going to take the absolute value of that, which is 2 times 4, and that's going to be 8. So the next one I'm going to be looking at is the last one, which is, or the number 2, which when I look and try to compare, which one does it fit into? So I'm looking at this 2. Is 2 less than or equal to 1? No. Is 2 between 1 and 5? Yes. So 2 squared minus 5, which is 4 minus 5, which is a -1. So that's my answer. So again, I'm going to take a test and see where does it fit, and then figure out which one it is. So for this last one, let's get another color. And when I try to figure out what's going on with it, 9. Is 9 less than or equal to 1? No. Is 9 between 1 and 5? No. Is 9 between 5 and 9? No, because it can't be equal to 9 there. 9 is greater than or equal to 9. True. So that means I use whatever this is. There's no x involved, so it's just that number. That's my answer. So let's look at the next page. And we're going to do the same thing. I accidentally put number 13 is the same thing as what we just did, so I'm not going to do that problem for you again. But let's look at the other ones. 4. Is 4 less than or equal to 1? No. Is 4 between 1 and 5? Yes. So 4 squared minus 5. So that's 16 minus 5, which is 11. That's your answer. So let's go to the next one. -6. Is -6 less than or equal to 1? Yes. So I'm going to use that one. So a -6 minus 9. This becomes a positive. So 6 minus 9 is -3. That's the answer. Let's go to the next one. 5. And I'm going to go through again the process. Is 5 less than or equal to 1? No. Is 5 between 1 and 5? It's not equal to 5, so no. Is 5 between 9 and 5, but could be equal to 5? Yes. So 2 times the absolute value of 5 minus 3. So 2 times the absolute value of 2, which is 2 times 2, which is equal to 4. That's your answer. And the last one we have on this section is 1. We have to figure out which group it fits into. Is 1 less than or equal to 1? Yes. So I need to do a negative 1 minus 9. So a negative 1 minus 9 is equal to a negative 10. That's the answer.